Hello everyone. Today we are here to discuss the KCET question paper along with its solution. So myself, Arun Shidling, lecturer in physics from prestigious University Gurudev PU Science College, Dharwad. So let us begin with our KCET discussion without wasting a lot of time as it is a competitive examination. So let's begin with it. So let's start with question number 1. So what is asked in question number 1? A block of mass m is connected to a light spring of a force constant K. Now here, as you go on reading, you understood that there is a word called as damping. That means it is a concept related to damped oscillation. So as you just go through the concepts, you clearly figure out that the right answer should be this option. The simple reason for that is the rest of all the options have the concept required for the damped oscillation. Only that one doesn't have one term, which I'm going to write it for you here. That is, any displacement equation should have the equation omega t plus phi. This one is valid for SHM, that is simple harmonic motion, in which it is undamped. The moment you have to, you take the concept of damping, then you need to multiply the term, that is damping factor, e to the power minus 2 e to the power minus b t divided by 2m. So whereas as you just see that you don't have that term in this point here, you don't see that here, so that's why I choose that the incorrect option is option D. Now moving to the next one now. In the next one, they are asking us the speed of sound in ideal gas at temperature T is V. So the speed of sound in ideal gas is V. So if this is speed of sound, I would better write it as a Vs. I'm just taking V is equal to Vs just to avoid confusions. The RMS speed of gas molecule at that temperature is VRMS. So the gas molecule speed is VRMS. I'm going to take it as same itself. Now the ratio of velocities of V and VRMS for helium and oxygen are X and X dash. That means we are supposed to do the ratio, the proper way of understanding that is I have to take X is equal to the ratio. If this is for helium, I'm writing this for what? Helium. Then I have to take the X value first. X is ratio of velocities V divided by VRMS. Here V is velocity of sound in helium. Now if I'm taking velocity of sound in helium, next if I write further, so according to the equations what we know, it should be root gamma RT divided by M, and this one is root 3RT divided by M. So as you try to further simplify, you would clearly understand that X would be root gamma divided by 3. So if you can clearly see that X is equal to root gamma divided by 3, this gamma is for helium. Like this, if you try to write it, then X dash would be, that is which is given for the oxygen, that would come out to be root gamma of oxygen divided by 3. If you try to simplify it in a very simple manner, then X divided by X dash, which is asked to us, would come out to be root gamma of helium divided by gamma of oxygen. As you know that helium is monatomic. Helium is which one? Monatomic gas. So you would have its ratio of specific heat value as 5 divided by 3, and oxygen's is diatomic, so you would have its value as 7 divided by 5. Simplifying this one, you would get your answer as 5 divided by root 21. This would be your answer for it. I hope you are following it. So you need to simplify it to get your answer. So now let's go to the next question, that is question number 3. So question number 3 is very conceptual one. There is no much discussion in that. If you read it, a positively charged glass rod is brought near an uncharged metal sphere. Once you bring it, you just try to induce charges on that. So you would try to separate positive charge on one side, negative charge on one side on the metal sphere, since it is a conductor. The moment you try to remove the glass rod, again it becomes uncharged. Reason is the whole metal sphere is having zero charge. So the right answer would be for this one is 0. So let us take the next question now. Fourth one. What's been asked? In the question they are asking you to find out the net torque, net force. So net force first, then net torque first. So I think by seeing this, you have clearly understood that this is a problem on dipole, electric dipole. Now I would like to answer it here itself, right here itself, by trying to simplify the concept. Just if you try to see this diagram, there is a negative charge here, positive charge here. And when you try to simplify and try to understand this, you would see that electric field line would start from here and would go in this manner. If I take electric field line, this is electric field direction. On the equatorial line, I am having electric field along this direction. This is E, equatorial. Now, since electric field is along this direction and I have a negative charge, the force will be in the opposite direction. I think you can clearly see that the force would be in the opposite direction. Now, force is in this direction on it, since it is a negative charge. So if it is a negative charge, force is in this direction. You can clearly say that if this is x-axis, I felt like that there was a need. I felt like there was a need for the question to be provided with the coordinate system, so that we could have told that it is I cap, j cap. But in the options, they have already provided I cap, j cap. No worries, we will try to assume that we are having some coordinate system like this, in which I am having x-axis here, y-axis here, and z out of the plane. So this one would clearly say me that the force is along I cap, right? So moving ahead here, I would just give the values for it. So the values would be like, I will try to first of all find out E equatorial value, E equatorial for the short dipole. Since it is a short dipole, as it is given to us, these values are given, you can see here. So just I think this R much greater than A, as it is given R much greater than A, I have to take it as short dipole to solve it. So I have taken E equatorial is equal to 1 divided by 4 pi epsilon naught. Equatorial value, this would be P divided by R cube. Now I have to find out force. To find the force, what I need to do, I would write F is equal to the charge into electric field on the equatorial line. So if you try to do this, you would get the answer as 1 divided by 4 pi epsilon naught PQ divided by R cube. And we know that this is along which direction, as I said it, it's along I cap. So I would mark it as I cap. So you can clearly see that here. So if this becomes vector, then I have to mark a vector sign here. So I'm sorry if I'm trying to do some mathematical error, but finally my intention is to give you the answer. So I'm giving you. So F is valid with this option. So let's find out F, which one is that? So I would just go with I cap here. So either one of them, either I would have to take this, either I would have to choose this one, that is B option, or else I would have to choose the D option. So either B or D, I have to select it, right? So either B or else D option I am selecting. So, but still they are asking us what would be the torque. So I would like to move to torque. So torque formula, as we already know it, torque is nothing but tau is equal to R cross F. Without lot of waste of time, I would just try to keep it very simple to you. That is, I'm going to just take the direction of this. You can see that the direction of R would be along this one, R. So R is along J cap. If you clearly note that R is along J cap. So if I try to write here, I would get it as R J cap cross the whole term. You try to put it here. So that is 1 divided by 4 pi epsilon naught P Q divided by R cube into I cap. So J cross I gives me, I think so it is a minus K cap. Now your task is to find out which option would match, either B or it is a D option. So when you clearly note or just check out, you clearly see that you should have minus, and clearly the option for me, that is clearly left out option, is option D. So the right option is option D for us. Now moving to the next question. Question number 5. So question number 5 is on kinetic theory of gases, pressure concept. So pressure of an ideal gas at constant volume is proportional to. We already have studied pressure concept. So pressure is given as 1 by 3 rho VRMS square. Now if you try to check this out properly, you would get that is M VRMS square divided by V, assuming that the volume is 1 unit volume. If I assume that volume is unit volume, so you would get it as 1 divided by 3 V VRMS square. Now just trying to do some minor arrangements in this, I would just write it as like this. Now when we write it this way, you can clearly say that this term would give me kinetic energy, and that would be average kinetic energy. So the average kinetic energy is the above equation. So pressure is clearly equal to 2 by 3 average kinetic energy of the molecules. So if I try to mark this, then my right option would be option B. Yes, hope you understood this. So let's move to the next question. Next question is question number 6. So question number 6 is from the first chapter, that is electric charges and fields, and it is on the concept of Gauss law. So Gauss law concept for the infinitely long straight wire that is being given here. If you try to take electric field at a point E is equal to lambda divided by 2 pi epsilon naught R, if R is the distance from the infinitely charged wire. This is the electric field which is being given. So I'll mark this as E1 as it is given in the question. So I'm not wasting time in reading the question. I hope you have read the question while writing the exam. So let's move to the next part, what they have given us. They have told that there is another uniformly charged conductor having same linear charge density lambda is bent into a semicircle of radius R. So let me take the semicircle whose radius is R. So let us take that this is a semicircle. So if this is a semicircle, then I have to find out electric field at the center. So if you want to find out electric field at the center, you have to use the concept of uniform charge distribution. Let me try to take a small part of this. Let me say that this is DL. Due to DL, I will have an electric field over here. This electric field would be DE. So if this is D, then you can write down further that the value of this one will be like K. K is nothing but 1 divided by 4 pi epsilon naught. Then the value of this further would come out to be dq. dq is the charge on this dl element which I have taken. The charge on the dl element. Then divided by the radius square, that is radius of the semicircular ring. Now further substituting the values, you can clearly see that it would be 1 divided by 4 pi epsilon naught. That dq, I would be writing it as in terms of linear density lambda into dl divided by r square. Now this is dE value. Trying to use this concept of integration to get the whole value of this electric field at this point. I think you have to try a lot to get the value. There are some shortcut methods and there are some concepts which you can see. So this electric field has to be split into two. The vertical components might get cancelled out and the horizontal components have to be added, and finally when you solve out the integration, you would get the value of this one to be E is equal to lambda divided by 2 pi epsilon naught r, and this is being told to us as E2. So therefore, by clearly seeing it, I get to know that E1 should be equal to E2. So the right answer for our question is, let's figure out that the right answer for our question is E1 is equal to E2. So sixth one we have solved. Now let's move to the next question. That is, next question is 5 capacitors, each of value 1 microfarad. So this concept is from second chapter, but it involves Wheatstone's network. It involves Wheatstone's network. Wheatstone's network pattern. So if you try to check, assuming that this is a, so let me try to say that, assuming this one to be C1 and C2 in this manner, let me say that is C1, this is C2, this is C3, C4. If you take the ratio of that, C1 by C2 is equal to C3 by C4, you would get it to be equal. Since it is equal, you can see that the capacitor here would not have to conduct, and the potential difference at these 2 points is same. The capacitor wouldn't be functioning anything over there, so it wouldn't be considered in the circuit. So it would be simple for me. So if I draw the circuit, the concept would be very simple as of this. So I would have 2 capacitors here which are in series in this manner, and this AB. So this is C1, C2, sorry, C3, this is C2, C4. Now try to do the value of this. First of all, these two are in series. The value of this is 1, this is 1. In series, if you take, it would be 1 by CS is equal to 1 by C1 plus 1 by C2. For that, the whole capacitance value, you would get it as 1 by 2. And for this, you would get the value as 1 by 2. 1 by 2 and 1 by 2 in parallel gives you totally C equivalent as half plus half. Sit and try to solve it. You would get the answer as 1. So our answer for this question is 1. So the right option for this is first option. Moving to the next one. Keeping the concepts very simple, I'm going to solve the next one very fast. So by seeing this problem, I hope you have understood that it is a concept on potential, that it comes from the second chapter, potential concept. So as I already know the concepts, I can clearly say that potential at A is greater than potential at B. Potential at A is equal to, is greater than potential at B, because along the direction of electric field, potential goes on decreasing. So as it decreases, we get to know that it should be equal to some value. So I'm going to give you that term. So I'm just going to write that potential at A is greater than potential at B. And if I try to take the difference of these two, that is difference between these 2 points. So if I'm trying to take here, if this is point A and this is point B here, so the difference of potential between these two, if I call it as delta V, it would be equal to E into X. I am using the concept of E is equal to dV by dx. I'm not trying to put the minus sign. Reason is I know that which one is greater, which one is lesser. So I'm trying to keep the concept very simple. Further moving ahead, I can clearly say that VA should be equal to VB plus this E into X. This is the additional difference between that, the difference between the two. Now if I want VB value will come out to be VA minus EX. And as they are asking us to find out potential energy at B, I'm going to write it as UB. UB is equal to, it comes out to be Q into the charge which is moved into the potential at B. As you can see, I have already wrote the potential value at B. So it is a VA minus EX. So I think you have found out the option for this, which is the right option. So the right option for this one is, So it is D option. Q in the bracket VA minus EX. This is the right option for it. Okay, let's move to the next question now. Next question is on capacitor. As predicted by us that electrostatics would have nearly 6 to 7 questions. It is clearly having 6 to 7 questions from electrostatics. I am combining the first 2 chapters and saying it. So let us try to move to the next problem and solve it. Here what they have given, there is a capacitor which has a dielectric slab in it. So capacitor having dielectric slab inside it would be clearly written with this manner. That is this dielectric constant. As it is not being told that there is a dielectric constant value K, I am writing it and assuming it. So I would say that this is a air-borne capacitor. That means air capacitor with air in between it or vacuum inside it. So capacitor with dielectric medium would be C1 is equal to K into C0. And next time they are telling that the dielectric slab is removed. You can clearly see that the dielectric slab is removed. If I remove the dielectric slab, you know that C2 should be equal to directly C0. Now by seeing this, you can clearly say that which one is greater. C1 is greater than C2. So the options which are allowing us to choose is C1 is equal to C1 greater than C2, C1 greater than C2. And this one would be wrong. Now I have to figure out whether it is V1 greater than V2, V1 is equal to V2 or V1 is less than V2. So for that I would just tell you, read the question properly and they are telling you the battery is connected to the capacitor and it has a potential difference V. And after that also in the next part they are telling you still the capacitor is connected to the battery. That means battery is going to give you the same voltage. It is going to provide the same potential difference across the capacitors. Whether it is C1 or C2, the potential difference will remain same because it is connected to the battery. So V1 should be equal to V2 in this case. So our right option for this one would be option B, not the other two. Yes, moving to the next question now. So the next question is on Gauss law once again. So it is on electric flux concept involving Gauss law also. So let us try to read the question. While you read the question, you get to know that there is a cube whose side length is 10 centimeter. Now they are telling you from one phase you are having a flux entering. So flux entering is 6 kilo Newton per coulomb, but we have to multiply area to that. So this is electric field which is given. Okay, so let us try to say that electric field E entering, I am saying entering means it is entering the cube. So the entering electric flux is 6 into 10 raised to 3 because it is given in kilos. And I'm going to say the entering flux would be taken as negative because we have studied that in our concepts that flux entering any surface would be taken as negative, flux leaving any surface would be taken as positive. So flux leaving I'm going to take it as positive plus 9 into 10 raised to 3. Further, what they are saying is try to find out the total charge inside it. I would apply the concept of saying that Q divided by epsilon naught is equal to phi. Phi is the flux, total flux through the cube. So total flux would be flux leaving plus flux entering. So but this one would be minus for us as I have taken it as minus, but I'm still going to write that flux entering. So if you try to sort it out properly, you would get the value here. So this is a electric field E leaving plus electric field entering into area, because I have to take area into consideration because area remains same in both the cases. I am taking it directly out. I just substitute the values of this one. So the value of this one is 9 and here you would get minus 6 and into 10 raised to plus 3 I am taking it here. Now area would be nothing but a square. A square means 100 and centimeter square comes out to be 10 to the power minus 4. So try to simplify this. You would get 9 minus 6 is 3 and here I think this would give me 30 as its value. So yes, 30 is the value of this one. So I got to know Q divided by epsilon naught is equal to 30. Now Q will be equal to 30 into epsilon naught value. I think epsilon naught value is given in the question, that is 9 into 10 raised to minus 12. So if you try to multiply the values and try to get its answer, you would land up with the answer as option B, that is 0.27 into 10 raised to minus 9 coulombs. Let's move to the next question now. So the next question is on resistors. Question is on resistor. This time 2 questions are asked on resistor concepts, that is especially on color coding. So what's asked in this question is, they have asked 4 bands of color coded resistors. So they have given gray, red, gold, gold. So if you try to clearly note that, we have resistor would be equal to, first blank will be for first band, second blank for second blank, third would be 10 to the power the blank which I'm going to fill up here, then plus or minus the tolerance of it, which one it would be. So as you have studied, there is a shortcut for it, BB Roy. So you have been gray color, so gray would come up here. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then afterwards comes the gold and silver. So I'm not writing them. So I'm just going to go with gray here, 8, and this is 2. And as you know, gold would be coming up with a value of minus 1. So this would be minus 1 here, and then it has a 5% tolerance. If you try to further simplify this value here, R would come out to be 8.2 plus or minus 5% tolerance. So the option that I'm going to clearly get here is the C option for it. So you can try it on your own. It's a very simple concept. Let's move to the next one. That is, we are having the next question on current electricity itself once again. And in this one, they are telling you a wire of resistance R is connected to a cell of EMF E and internal resistance R. So try to sit and figure it out what I should get. They are asking me clearly work done, and I know from my concepts that power is equal to work done upon time taken. So work done according to me would be power into time. Power into time. So power would next can be written as V into I into T. So most of them might have converted this V itself as EMF and have written the option as either D or else this one, or all of them are right. No, not all of them are right. Reason is, this is a terminal potential difference. Since they are telling you that it is EMF of cell is E, EMF of cell is E. So since they are saying us that EMF of cell is E, since they are saying that EMF of the cell is E and internal resistance is R, so you can clearly understand that EMF is present, or EMF can be taken only when the internal resistance isn't there. Now, if you are having internal resistance, then I have to take terminal potential difference. So I'm not willing to take the terminal potential difference. I would better try to write this in terms of Ohm's law itself. I'm going to change this as I into R into IT. So this would come up to be I square RT, and this would be our right option. So the option is B option that is being given here. That is B, that is I square RT. You cannot take this option A and you cannot take the option other option. The simple reason for that is this is obviously not right. You cannot take the other options which are involving EMF. The simple reason is there is presence of internal resistance in the question. Let's move to the next question now. Next question is saying us clearly about the mobility, and you can clearly understand this is also from current electricity concept. So since it is current electricity, let's try to figure out about mobility first, because mobility, already we know that it's nothing but drift velocity per unit electric field. And as we already know, drift velocity expression is known to us. That is, drift velocity is E tau divided by m. I am taking the magnitude of it because the definition of mobility is for magnitude of drift velocity. So if I try to substitute this one here, you would get that E tau divided by m. And here you can clearly see that E is a constant number, mass of electron is also a constant number, and this tau is temperature dependent. Relaxation time is temperature dependent, but they have in the question mentioned that the current is increased at constant temperature. So the temperature is constant, so relaxation time wouldn't change. So I am having a clear idea of mu should remain constant. Mu should remain constant here. So if mu remains constant, then which are the options? Let me check it. So I am having two options for myself, that is either C or else the option would be D. Now let me try to figure out what would happen to the question about drift velocity. What would happen to drift velocity? So we have already also studied that I is equal to NEA VD. So from this, if you try to figure out VD should obviously increase to increase the current. So it would come out to be I divided by NEA. So if I increases, then VD increases. So my right answer would be option D for this one, not the C option. So let's move to the next question now. Next question is on same chapter, current electricity, and it's about combination of cells. So here how many cells are given to us? 10 cells are given. In these 10 cells, each cell has a EMF of how much? 2 volt. Internal resistance how much? 1 ohm. They are connected in series. And we already know the formula for series combination of cells. It would be like E1 plus E2 plus E3 plus so on, how much ever you go on connecting, so on. But there is one catch in that, that is you should connect all of them in the same order such that they give the current in same direction. Since they have told that two cells are connected wrongly, there is only one possibility of connecting wrongly, that is in the reverse direction. So you clearly understand that series combination of cells has 8 cells in a proper manner and 2 cells are in reverse manner. 8 cells are giving you a proper mannered combination, the right one which we want. The other 2 are wrongly connected, that is oppositely connected. So you can clearly say that it is 6 times E, and you know 6 into EMF of each cell is 2. So your value for that is a series EMF is 12 volt. Next, they are telling that there is external resistance, and now also we have to find out the internal resistance of all the cells. So internal resistance, small r, yes, I would write. So it would be R1 plus R2. Here, whether you connect them in reverse, any combination, whatever you say, resistance would always get added up in series. So you just need to add them. So if you add them, you would get total resistance as 10 resistors, identical resistors, that 10 into 1. So your answer for series resistance would be 10 ohms. Now let us try to draw an equivalent circuit for this. So if I try to draw equivalent circuit for this, then I would get a cell along with its internal resistance here, and then a external resistor R and current I flowing in it. What we are asked? We are asked how much current flows through it. So I need to write expression for current. So let me try to write that this is external resistance R and this is internal resistance RS of the whole combination equivalent circuit, and this is ES. EMF. Now, according to the knowledge what we have, I can write according to Ohm's law, ES, the total potential, net potential ES will be equal to current into the total resistance. So if you see that the current flows here, it is actually flowing through this as well as through this. So that's why these two resistors comes out to be in series. Don't try to take them as parallel. Try to think of current, same current is flowing through both. That's why they both are in series. R plus RS. Now try to simplify the problem, you would get your answer. This one is already 12 given to you, and this is I, and here the external resistor is 10 ohms. 10 plus RS also I have found out, it is 10. So this would be 12 divided by 20 is equal to I, and you can clearly say that the answer is 0.6 ampere for this one. The answer for this question is 0.6 amperes. So let's move to the next question. Next question is also from current electricity. This question is on equivalent resistance between the 2 points A and B. This is on ladder network. There is a direct formula for this one which you can substitute and calculate it. I would have plenty of methods to solve it, but I would say suggest it how do you have solved. It would be very simple if you have done it by there are two methods. I would go with the iterative method without trying to have a lot of complications. I would just try to keep it very simple. I would just take the circuit. First of all, I'm going to take this part of the circuit. So maybe I'll just clear it and give you the concept. I would take this part of the circuit. First of all, I would take this region of the circuit. Can you tell me what will be the value of it? Take only this much portion of the circuit. So it's better I would draw it here to make it very simple. Maybe I am consuming more time. The only reason is trying to give you the answer accurately and make you understand the concept. So I'm going to take these. First of all, I'm going to take this whole bunch, and the value of this one comes out to be 2 plus 2 plus 2. Because they are in series, you will get 6 as the value. So further, if you try to take this, the value of this one is 6. Now this 6 is in parallel with this one. So if you combine this 6 is in parallel with this 2 ohm resistor. What is 6 parallel to? 2 into 6 divided by 2 plus 6. This gives you how much? 12 by 8. 12 by 8. 12 by 8 is 3 by 2. 3 by 2 is how much? 3 by 2 is 1.5. If you wish to, you can keep it as 1.5, or else you can proceed like this in the same manner. Now I will try to combine this whole thing. Combining this whole thing, that is 2 ohms and 3 by 2 plus again 2 ohms here. This is 2 ohms, this is 2 ohms. You stick on with the concept, try to think what I am trying to tell you. 2 plus 3 by 2 plus 2. So what do you get here? 4 plus 4, 8. 8 plus 3 is 11. 11 by 2. This is your value. The value is 11 by 2. You can clearly see that. So 11 by 2 would be 5.5. If you wish to, you can make it 5.5 and solve. Now this 11 by 2 is in parallel with which one? 2. 11 by 2 is in parallel with 2. I am just trying to extend this and make it very simple here. So make 11 by 2 parallel. So parallel will be 11 by 2 into 2 divided by 11 by 2 plus 2. So I think this 2 cancels this one. So you are left with 11. In the denominator you are having this one. So multiply to this. So you would get 15. 15 divided by 2. 2 goes to the numerator. So it would be 22 divided by 15. So again, this 22 has to be added to these two. That is 2 ohms and 2 ohms. Now sit and try to figure it out. That is 2 plus 2 plus 22 by 15. The answer for this one itself is nothing but the equivalent resistance for this, R equivalent. So this is your answer for R equivalent. So R equivalent comes out to be 5.4, 5 something like this. And since it is very close to 5.5, I am choosing this answer. So since it is very close to 5.5, I am choosing this answer. So which option? Option A, I am choosing it. I think you understood it. I am just trying to do it by the iterative method, or else there is a shortcut for it, which I am not trying to give you because you have not studied it. So if you would have been at our institute, you would have studied that shortcut and you would have cleared it within fractions of seconds. So let's move to the next question now. So moving to the next question. That is, a charged particle is subjected to acceleration in a cyclotron as shown. The charged particle undergoes increase in its speed. So when its speed increases, its speed will only increase in the electric field. And where is the electric field present? The electric field is present only between the gaps of D1 and D2, because electric field accelerates the charge, whereas magnetic field doesn't accelerate it. It only changes the direction of the velocity. So here only between the two D's the charged particle will get accelerated. So the right option for this one is D. Only in the gap between D1 and D2. So let's move to the next question now. And this question was previously, the cyclotron is from which chapter? Moving charges and magnetism. Now once again you can see on current electricity we are having one more question. The question is on resistance of carbon resistor. So that is color coding once again. Now in this one you need to figure out how to simplify this one and get the answer. So let me try to write down that properly. That is 4.7 kilo ohms plus or minus 5%. I'll just teach you how to decode this. That is just first of all, try to write this 2 properly as a digits. Try to make it a digit. That is, you would get 4.7 as 47, you have to make it. And then this was 10 to the power 3, right? It would become 10 to the power 2. Then plus or minus 5%. Now you can easily decode it. So this one is for, if you try to write B Roy concept, you would clearly get to know which color it is and what it would be. So this is 0, 1, 2, 3, 4, 5, 6. So 7 I need. So it would be V7. Now this 4 is for which one? Yellow. Yellow you would get. Violet for 7. Violet. But they are not asking this one. They were asking us what is this, and this is what? Red. So my answer for this question would be red is my answer for it. Which option is right for it? The option number is A. A option is right for it. So red is the right answer for this question. I hope you got it. Now let's move to the next question. The next question here has come from, it is question number 18, has come from which chapter? It is from moving charges and magnetism. Moving charges, magnetism question. So this question is asked on galvanometer concept. This question is asked on galvanometer concept, and galvanometer's conversion it is asked. So galvanometer converted into ammeter. So galvanometer converted into ammeter. How can we convert a galvanometer to ammeter? A galvanometer must be connected along with a shunt resistance S to convert it into an ammeter. Isn't it? So as we already know that for this we are having an equation. That equation is I, that is Ig, the current required to give you full scale deflection in the galvanometer. To deflect it completely, what current is required? Ig current is required. Ig into G. This gives me potential difference across G, and same potential difference should be across S also. If I current enters here, the remaining current that it should enter here would be I minus Ig into S. So let us check the values which are given into for us in the question. The values that are given in the question are: a moving coil galvanometer is converted into ammeter of range. How much is the range of this? The range of this one is, the range of this one is how much? 5 milliamperes. 5 milliamperes. Just a minute. The value of this one is 5 milliamperes. So that 5 milliamperes is nothing but our range of the galvanometer. So that I would take it as. So just I will directly go on substituting the values, and you can try to clearly write it down and note it down here. So moving coil galvanometer is converted into a range of 5 milliampere. So this is 5 milliampere for us. So this 5 milliampere. Then next, what else is given? They have given us galvanometer resistance. This is 90, and this S value is how much? It is 10 ohms, and this is 5 milliampere. From this you have to find out the value of Ig. So just trying to simplify this, I think I would get that this is 90 Ig is equal to 5 milliamperes. I would write 5 into 10 raised to minus 3, and this 10 I would multiply into the bracket, and I would have here 10 Ig for this. Take this 10 Ig on this side, you would get 100 Ig is equal to this. If I try to simplify this one, it becomes 5 into 10 to the power minus 2. Now try to simplify this further, you would get the answer as Ig is equal to 5 into 10 to the power minus 4. So this is your value of Ig. And what is Ig here? Ig is the current required for full scale deflection of the galvanometer. If you want to deflect the galvanometer for full scale, complete 50 divisions, what is given in the question, 50 divisions you have to deflect it, you need this much amount of current. So remember this value. We are going to move to the next page to solve it. So I'm going to move to next page by remembering this value. So as I already have studied from my previous concepts, that is, if I is the current through the galvanometer, it will be proportional to the deflection in the galvanometer. So if I try to write I is proportional to theta, then I equals to K into theta. What is K here? Figure of merit, which you have studied in your practicals as well as theory classes. Figure of merit. And as they are asking us, what is the current sensitivity? Current sensitivity is a reciprocal of figure of merit. Current sensitivity is what? Reciprocal of figure of merit. Current sensitivity is reciprocal of it. So I would write it as 1 by K. So if you try to take 1 by K, then your value should be nothing but theta divided by Ig. So we have these two values. Theta is given to us, that is 50, and Ig value is 5 into 10 raised to minus 4. So trying to simplify this, your answer would come up to be, what would be our answer? Our answer would be, I would cancel this one with this. So if this goes to numerator, so it comes out to be 10 to the power 5. 10 to the power 5 division per ampere. So B option is right for this one. Yes. Moving to the next question. The next question is 19th one. A positively charged particle of mass m is passed through a velocity selector. Positively charged particle is passed through a velocity selector, and it is exactly on the line. So as they are saying you that it is placed on the line, then you can clearly say that the line here has its value all the time. Y value would be 2mv divided by qb. And next, if you try to figure out and solve it out, you would see that the moment you try to switch off the electric field, it will try to go in this manner. It would try to move along this direction. So once it is going on the other side, then obviously the value what you would get from the center or from this point to here would be much greater. And if you try to figure out and solve, none of the options of this question would match to the, that is, none of the options are matching to the final solution of the question. So I would say that this question is somewhere having some error. That's why we are not able to figure out which option is right. So that's why I would clearly say that no answer is being given in the options. None of the options match. Yes. So most probably this is a doubtful question. So let me move to the next question. Next question is on Curie's temperature, and you clearly know that this is coming from a chapter, magnetism and matter. So as we already know, it is asked on susceptibility. Let's try to move on susceptibility concept now. So susceptibility, you can see that susceptibility. So susceptibility formula is chi is proportional to 1 divided by T minus Tc. But they are saying us that Curie's temperature for cobalt is 1400 Kelvin, 1000 Kelvin. So if you try to see that, I have to write it, or you have to find the ratio of chi of cobalt divided by chi of iron. Chi of cobalt by chi of iron. Now if you try to write this, you would see that it is inversely proportional. That's why you will have T. This would be for iron, which would be which is already given there. This is T, the general temperature which is given here. So it would be same for both. T minus T of which one? So inversely proportional. So this would be Curie's temperature of iron divided by T minus Curie's temperature of cobalt. So substituting their values, I think you would get here 1600 minus this iron's value is 1000 minus 1600 minus 1400. So if you try to simplify, you would get here 600 divided by 200. 600 divided by 200 is 3. So the right answer for this option is option A. So we have successfully solved the question number 1 to 20, and the rest of the questions will be followed by my colleague Nagraj sir would continue it.
Hello, welcome to Gurudev PU Science College. Myself Nagraj Durganavar, and I am a physics lecturer. Yes, already my colleague already completed the question up to question number 20. Now we will discuss from 21. The question number 21 is the torque acting on a magnetic dipole placed in a uniform magnetic field is 0 when the angle between of the dipole axis and the magnetic field becomes what? They are asking. So here we will see this is the magnetic field and we are placing here a magnet, and here it will be a north pole and here south pole, and this would be south pole and here north pole of the magnetic field. Now this one here, the formula for torque is equals to M cross B, right, which can be written as torque is equal to MB sin theta. And in the question they are telling that the uniform magnetic place is torque, this torque is 0. So therefore if I choose this torque as 0, this would be MB sin theta. Therefore theta will become also 0. So our answer is theta is 0. The option is D. Yes guys, now we will move to the next question, which is 22. One minute. Yes. Yes, thank you. Question number 22. The horizontal component of Earth magnetic field at a place is, the horizontal magnetic field component is BH, which is given 3 into 10 to the power of minus 5 Tesla. Okay, then if the dip at that place is 45 degree, then theta is 45 degree they have given, and then resultant magnetic field of that place, the resultant magnetic field is given by the formula resultant magnetic field of Earth is equals to under root of BH square plus BV square. Here I know BH, but BV I don't know, but one hint they have given, that is theta equal to 45 degree, that we know that BV by BH is equals to tan theta. If you substitute here theta is equal to 45 degree, then it would be BV is equals to BH. Therefore the resultant magnetic field is equals to under root of, as BV equal to BH, that is 2BH square, which can be written as under root of 2 into the original value of BH is what? That is 3 into 10 to the power of minus 5 Tesla. So this is the answer. So here option number B is correct for the 22 question number. Now we will move to the next question, that is 23. A proton and an alpha particle moving with the same velocity enter a uniform magnetic field with their velocities perpendicular to the magnetic field. The ratio of radii of their circular paths. As we know that any charged particle placed in a uniform magnetic field, they start moving in a circular path, and we know that radius of that circular path. I will draw one example here. Diagram for that. This is uniform magnetic field. If you place a charged particle, that charged particle moving in a circular path, and this circular path has a radius r, and that radius is given by mv by b into charge q. So from this one we can say, here they have given radius of which particle? First one, proton and alpha particle, divided by alpha particle, which is equal to mass of proton divided by mass of alpha particle into, it is inversely proportional to charge. Therefore you can say alpha particles are 2 charge, therefore 2q divided by proton is just q charge, so q get cancelled, and here mass of proton is mp divided by mass of alpha particle is 4 times of mass of proton into 2, so mp get cancelled, 2 ones are 2 get cancelled. The answer is 1:2, that is 1/2. Therefore our answer is, that is ratio of rp is to r alpha is equals to 1:2. So the answer is second option, that is B option. Yes. Now we will move to the next question, 24. The question number 24. Yes, guys. So the question number 24 is that a metallic rod of length 1 meter. There is a metallic rod of length 1 meter. It is held along east-west direction. This is east, this is west direction. Allowed to fall down freely. So it is allowed to fall down freely. When it is freely falling, what is the initial velocity? The initial velocity u is equals to 0. Then component of Earth's magnetic field they have given, that is BH, is given how much? That is 3 into 10 to the power of minus 5 Tesla. Then the EMF induced in the rod at an instant, time t equal to 2 seconds after released, right? So here the question is that how much EMF induced in the coil. So here whenever a rod is placed in a uniform magnetic field, that EMF induced can be given by a formula, E is equal to BV L sin theta. Anyway, theta is 90 degree here between rod and magnetic field. Therefore, sin 90 is 1. Sin 90 is equal to 1. Therefore, EMF induced is equal to BVL. So here B we know, which is BH. Velocity we need to calculate now. So for a freely falling body, the velocity formula is equal to V is equal to U plus GT we used to take. And V is equals to initial velocity 0 plus G and how much time? That is 2. Therefore, we can say that V is equals to 2G. Now substitute in this one. So induced EMF is equal to magnetic field 3 into 10 to the power of minus 5 and velocity will be 2 into G is 10 and length is 1 meter. Therefore, the answer is 6 into 10 to the power of minus 4 volt is the answer. Therefore, D is a correct answer for 24. Now, the question number 25. So here guys, this loop is 2 centimeter. This total magnetic field is 10 centimeter and magnetic field is given 0.5 Tesla. Now what is happening here? When this loop entering here, the one side of this upper surface of this loop area, here the magnet induced EMF will be anti-clock direction. Okay. So therefore, but they have said that, I'll draw that diagram again here. This is a loop. This is uniform magnetic field. Okay. So whenever this is moving with a velocity of 2 centimeter per second, so this is also length also 2 centimeter. And when it enter here, the whatever magnetic field produces or in EMF induced here, this is anti-clockwise. Therefore, they said take clockwise direction as positive. If it is anti-clockwise, the whatever the EMF induces, which will be minus d phi by dt, because flux link with the coil induces EMF, that is d phi by dt, which we get as 2 into 10 to the power of minus 4 volt already they have given. Now, when it enters, so here which option is correct? These two are wrong because directly we cannot take them values because they are constant now. It is not constant, it is entering, no? So it increases, but with the negative sign is there. So out of, if it is taken for a positive sign, but here we have taken negative sign, that's why the option is this one. You can see here between 0 to 1 second, this complete loop will enter into this magnetic field. At that time, the magnetic induced EMF will be increases, and then after that it will be inside uniform magnetic field. The area will be complete. There is no change in the EMF. Therefore, it will become constant. Again, when it enters outside after 5 seconds, 5 to 6, the magnetic field, the induced EMF decreases, but it is in the negative sign. Therefore, this option is the correct option. So, guys, for the 25th one, the option number C is correct. Yes. Next, we will see. We'll go to the 26th question. What is 26th question? The in series LCR circuit at resonance, the phase difference between voltage and current, right? So the at resonance, XL is equals to XC, which is there is no opposition from XL and XC, only opposition from resistance. It will be like this, that equation becomes only the current is passing through only okay, so only through resistor. In resistor there is no phase difference. Phase difference is 0 between current and 0. Therefore the answer is D option. Okay guys, next we will move to the 27th question. 27th question is that an ideal transform has a turns ratio of 10. What is the turns ratio? That is NS divided by NP is 10. Okay, then primary is connected to 220 volt hertz as a source, the power, output power. There is a one character, no need to solve this problem. There is a characteristics of ideal transformer. Here we have to focus on this ideal transformer. So what is the characteristics of ideal transformer? For ideal transformer, output power must be equal to input power. This is enough to make you the decision. That is, for ideal transformer, output power is equal to input power. That's all. So here the answer is C option, that is equal to power input. Now 28th question. We will move to the next question, 28. That is, the current in a coil changes from. So current is changing from where to where? That is dt. 2 ampere to 5 ampere, that is 5 ampere minus 2 ampere, which is 3 ampere. There is a change in current. Then in time, dt, in how much time? That is 0.3 second. Then the magnitude of EMF induced in the coil is 1 volt. That is, EMF induced in the coil is 1 volt. The value of self-inductance of the coil. Self-inductance formula is that magnitude of EMF E is equals to L into di by dt. After substitution of all these values, you will get L is equals to E into dt divided by di. So substitute all the values, you will get 100 millihenry is the answer. Okay, yes guys, the option is first option, that is 100 millihenry. Next, 29th question. Now we will move to the 29th question. That is, the ratio of magnitudes of electric field to the magnetic field of electromagnetic waves. So this is from electromagnetic waves. We have a formula, that is E by B or E naught by B naught is equals to C. So what is C here? Speed of light, whose value is 3 into 10 to the power of 8 meter per second. Therefore, the ratio of electric field and magnetic field of electromagnetic wave is the order of 10 to the power of 8 meter per second. So here the answer for that is B option. Correct? So for 29th question, B option is the correct answer. Now next, 30th question. That is, for a point object, which of the following always produces virtual image? Here the word is that always. That is very much important, and they are asking here lens. So out of these, plano-convex lens, biconvex lens, convex mirror, concave mirror. So out of that, so convex mirror is the correct answer, which always produces the virtual, erect and diminished object. Okay, diminished image. So option is C. For 30th one, option is C. Now 31, for a given pair of transparent media, the critical angle for which color is maximum, right? So we have a formula that critical angle C is inversely proportional to refractive index. Okay, inversely proportional to refractive index, and refractive index is inversely proportional to wavelength. Correct? Therefore, we can say that critical angle is directly proportional to wavelength. For out of red, violet, blue and green, red has a maximum wavelength. So lambda for red is having a greater value of wavelength, that is more value. Therefore, critical angle will be maximum because they are asking which color is maximum. Therefore, the color is red. I hope you understand, guys. So, answer is red value. Okay, red color. Then, next question 32, which is an equiconvex lens is made of glass refractive index. It is an equiconvex lens. Okay, its refractive index I will take it as L, which is equal to 4/3 when it is placed in air. Then focal length, the focal length of this equiconvex lens is F, they have taken. It is completely immersed in a water. Next, what they will do, they will take one beaker, in that water is there. In this water, this convex lens is placed, completely immersed, and the water, this one is refractive index of water is 4/3. Sorry, which means this NL is 3/2. NL is 3/2. That is what refractive index of lens. This is refractive index of water. The change in the focal length, the percentage change in the focal length, right? To calculate this one, first we will calculate focal length formula for lens. That is 1 by lens is equals to refractive index of lens minus 1. Anyway, two surfaces are there. Therefore, it will be 2 by R. Similarly, for water combination, 1 by water and lens is equals to NL divided by N water. That is NL by N water is what? Refractive index of lens divided by refractive index of water minus 1 into again R by 2. Sorry, 2 by R. 2 by R. So if you solve this one, you will get as focal length of lens is R, and if you solve this one, you will get focal length of water and lens combination is 4R. Now you have to change find out the change in the focal length. That is focal length FWL minus FL divided by FL. Correct? So if you find this one, you will get the answer. That is, if you substitute this value, you will get a 300%. 300%, and whether it is increase or decrease, how you are going to calculate? That is by using these two formula. That is FWL divided by FL is equal to 4, which is positive. If it is positive, it is increasing. Therefore, the value is increasing. So 300% increasing. So the answer is 300% change in focal, but it increases. Now, another question is that from the same chapter of ray optics, that is 33. 33 question is that a point object is moving at a constant speed of 1 meter per second and along the principal axis of convex lens. So this is convex lens. Okay, principal axis, object, velocity of the object is 1 meter per second. Same way, image is also 1 meter per second. Okay, then focal length of this lens is 10 centimeter. Now you need to calculate what object must be placed at certain distance from the center of the lens to have a speed of 1 meter per second. Okay, so to do so that, we will take this formula, that is square of the image distance by object distance into speed of object into object equal to speed of image. Okay, I'll write this one here, speed of image. Okay, see here, speed of object, speed of image, both are same, therefore they will get cancelled. Therefore v square is equals to u square, or we can say if v square is equal to u square, magnification is 1. Correct? And we have a formula in terms of magnification in terms of focal length, that is m is equal to focal length f divided by f plus u. If you substitute these values, no, f minus u, f divided by f minus u. So using this formula, substitute all these values 15, 5, 20, 10. So for which value you will get a magnification as 1? That is possible only for one value. If you substitute here 20, then only magnification 1. You can see here. You can see here magnification to be 1. This is 10 divided by 10 minus of 10 20. That is the only possible value to get magnification as 1. Therefore, this is the answer for 33 question. Now 34, that is when light propagates through given homogeneous medium. When light propagates through given homogeneous medium, the velocities of, see, that is a very important term, is that homogeneous. When light traveling through homogeneous medium, the speed or primary wavefront and wavelets are equal, right? So the option, this is by concept, that is homogeneous medium, primary wavefront and wavelets are equal. So B option is the correct. For 34th question, B option is correct. Now we will move to the next question, 35. So 35th question is based on alternating current chapter. So here what he is given one graph. In that graph he have given two information. One is Z and another one is omega. So as we know that omega is equals to 2 pi f, nothing but omega is in terms is nothing but frequency. So the total impedance of series LCR circuit varies with the angular frequency AC source connected as shown in the graph. The quality factor formula in terms of resonating frequency is that resonating frequency divided by bandwidth. Now here what is bandwidth? The bandwidth comes between these 2 points. Okay, so those 2 points are the bandwidth. Nothing but I can write the formula resonating frequency divided by bandwidth, which is f2 minus f1. So here directly they have not given frequency, but they have given angular frequency. Therefore I can take here this formula becomes 500 is a maximum, because at minimum resistance maximum current will be there. Therefore 500 divided by, this is how much, 600 minus 400 minus 400, which is equal to 500 divided by 200, 2 ones are 2.5. Therefore the quality factor is 2.5. Okay guys, yes. Next we'll move to the next concept, next question, that is 36. 36 question is based on the Young's double slit experiment. This is a slit, this is a central fringe, and this is a first fringe from the central bright fringe. Okay, then so this distance they have given that x, and they have given x written as x is equals to beta by 3, and we write beta, this x, as delta d by d. Okay, then so here beta formula is lambda d divided by 3 times of d, that is x we got. Then from this one we can find out delta d. So here delta is there. So what is delta d? That is the distance. The delta d or d is equals to lambda by 3. So from here lambda is equal to 3 into delta d. 3 into delta d, or delta d is equal to lambda by 3. Now here phase angle is equals to 2 pi by 3. If this is case, then phase angle is 2 pi by 3. After substituting resultant intensity formula, I is equal to under root of I naught square plus I naught square plus 2 I naught square cos pi is what? 2 pi by 3. After substitution of all these value, that again you will get I is equal to I naught only. So already they have given I naught, which is how much? 2 into 10 to the power of minus 2. The same I naught value will be the correct answer for this particular problem. The next 38th question. In 38th question, we have a formula regarding Einstein's photoelectric equation, that is energy E is equal to work function plus kinetic energy. So h nu is equals to work function is h nu naught plus EV, correct? So here you want potential because across y-axis you are taking a potential, across x-axis frequency. Now arranging this one, E electron volt is equals to h nu minus nu naught. By taking this potential here, E will be down, so this will be E will come down here into nu minus nu naught. Then comparing this equation with a y equal to mx plus c. So where m is the slope, so here h by e is the slope. H by e is the slope of the equation. Therefore, in the, out of 4 options, the first option is this one, right? The fourth option is the correct answer for 38 question. That is the slope, and remaining another one is y-intercept. Y-intercept is h nu naught by e is the answer. Now we will go to the 39th question. 39th question. In Rutherford alpha scattering experiment, impact parameter increases. So what is this impact parameter? This is the nucleus. This is the central line of the nucleus. This is the particle which is moving. Later it will deviate, right? So this is the impact parameter, that is B. If this impact parameter increases, this theta will decrease, right? This is the formula. This is quite concept. So as impact parameter increases, theta would decreases. Therefore, the answer here is directly C option. Now next 40th question. So here 40th question is that the energy level of hydrogen atom is they have given and the corresponding wavelength are emitted. So here if you observe this diagram, that is like this, right? This is energy E1, energy E2, energy E3. So here the one line which is coming from like this and another one will be like this and third one will be like this. From this equation you can say that E2, is it right this? Yes, this is lambda 2, this is lambda 1, this is lambda 3. So this is E1 because this is the first line, no? So E1, E2 is there. So you can take, this is E1, E2, E3. I will take this one as like this, A, B, C. That is AC energy is equals to BC plus AB. So AC energy is what? AC energy is H nu divided by lambda 2, which is equal to, sorry, H nu will not come here, HC will come. So HC by lambda 2 is equal to HC by lambda 1 plus HC by lambda 3. Then HC will get cancelled. Then after solving this one, you will get it lambda 2 is equals to lambda 1 into lambda 3 divided by lambda 1 plus lambda 3. So this is the answer. Therefore, the right option for this one is, that is B option. For 40th question, B option is a right answer. Yes guys, we have completed all 60 questions. If you have any queries, you can contact our college. You can visit our college. Thank you one and all.
Hello my dear friends. In fact, I am your physics teacher Uttam Kumar Umarji from prestigious Gurudev PU Science College. I welcome you to this niche discussion session on KCET question papers. So my colleagues have already discussed the questions from 1 to 40, and today let me just go ahead and give you a quick grub on 41 question, number 41 to 60. So without much ado, now let's go ahead and crack those questions. Now if you just observe here, the 41st question, which talks about Malus law. So the Malus law, according to Malus law, I can write the expression as I is equal to I naught into cos square theta by 2. So this is Malus law, right? So over here, as you can notice, they have given I value. I value has been given to us as I naught by 4. So if you just go ahead and substitute that here, then I'll be obtaining it as what? I naught cos square theta by 2. So we can cancel off this I naught on either side. Okay, accordingly, we will be obtaining cos square theta by 2 is equal to 1 by 4. So that means cos theta by 2 will be equal to 1 by 2. So I need not go ahead and give you the answer. Now what is cos theta by 2 equal to 1 by 2 implies? It implies theta as we can notice here, in fact, we can write this as cos square theta only. Okay, so I'll just write it as cos square theta. Okay, so hence I can easily go ahead and write cos theta is equal to 1 by 2 or theta is equal to 60 degree. So our answer, my dear friends, in this particular question is 60 degree. Hopefully it is clear. Now let's progress to question number 40. Now let us continue to our next question, that is question number 42. Now question number 42, it is based on the chapter nuclei. Now as you can notice here, it is given that initial mass number is 220 and this nucleus is in state of rest. Okay, and Q value has been given to us as 5.5 mega electron volt. Now we should find kinetic energy of alpha particles. Now the trick to this problem I would like to tell you is initially we will understand the total Q value. What is the Q value formula? Q value formula, if we just talk about Q is equal to, it should be energy of the product minus energy of reactants. Now reactants, I would like to say alpha particles, so hence I am writing K alpha here. So if you just consider the sum of these two, now this will be what? Total energy of the reactants minus what is the initial energy? Initial energy is 0 because as you can see they say that initially the nucleus is in state of rest. So according to that I can go ahead and address to this. So let us go ahead and substitute the values here. So I can write 5.5 is equal to Kp, that is kinetic energy of, instead of writing Kp, I will mention it as K of neutrons, nucleus, plus K of alpha. So I will mention like this. Now let me consider this as our first equation. So now let us apply conservation of linear momentum, because since there is velocity which is coming into play after the reaction, so clearly I would like to apply conservation of linear momentum. So according to conservation of linear momentum, what is initial momentum here? Pi is 0, right? Because nucleus is in state of rest. Okay, and this must be equal to what? Final momentum. What is final momentum? It is momentum of nucleus plus momentum of alpha particles. Now this is where I'm going to obtain the kinetic energy. Okay, so now let me just consider magnitude wise, we can say that momentum of nucleus and momentum of alpha particles, they are equal in magnitude. So that is why their sum we can take it to be what? 0. So over here I can go ahead and apply the formula for momentum. What is formula for momentum in terms of kinetic energy? It is square root of, I'll write here, okay, square root of 2mk. This is with reference to nucleus, so root 2mkn, that should be equal to square root of 2mk alpha. We can mention like this. Okay, so accordingly, as you can notice, they have given mass number, initial mass number is 220. So hence for this nucleus, let me go to next page here. I hope you have addressed to this, you have understood this. Now over here as per my equation goes, so I can write this as square root of 2 into 220 into K of nucleus. Okay. Now this should be equal to what? Square root of 2 into 220 into Kn, I will say, is equal to square root of 2 into, now as we can notice it is alpha particle, so hence I will be writing it as 4 into K alpha. Then according to that, now if you just simplify here, I can cancel off 2, and then over here I can write this as, and I can square on either side, so hence I'll get this as 220 Kn is equal to 4 K alpha. So that means I'll get K alpha is equal to 220 divided by 4. This is what I'll be obtaining. So 220 by 4 times of Kn, which will be nothing but 55 Kn. Now, next job, we will be addressing to the equation 1 that we have devised earlier. As you can notice here, previously we had this equation 1. So in this equation 1, I'll be substituting the value that I have obtained. So hence I'll get this as 5.5 is equal to 5.5 is equal to, I can write K of nucleus plus 55 K of nucleus. So this will be, therefore K of nucleus will be equal to what? 5.5 divided by 56. That should be somewhere about let me just bring it back. So it will be somewhere about 0.098. Okay, 0.098. So now this value I'll make use of and find the value of K alpha. Okay, so K alpha, we know that it is 55 times of Kn. So if you just put this here, then 0.55 into 0.098, that should work out to be approximately around 5.4. So in this question, our answer is 5.4. So this is what we have. So this was question number 42. I hope you understood the approach to this problem. Now let me move on to the next question quickly. Now this is based on radioactivity. Now they have given half-life as 3 years. Okay, half-life is 3 years, and they say that n value is 1/5 of n naught. So that is what they are saying here. So I'll just mention firstly T half. T half is 3 years. Okay, and they have given n is, they have given n is equal to n naught by 5. This is what they have mentioned. They want us to find the time required to have this quantity. Now, to get the time required to have this quantity, as you can notice, we have two major formulae that we can make use of. So first formula would be T half formula. T half is equal to 0.693 divided by lambda. Okay. Now by using this, we will find the value of lambda. So lambda can be written here as what? 0.693 divided by T half. Okay. So this is what we have. So, and we know that one more equation, that is decay relation that we have, that is n equal to n naught into e raised to minus lambda t. Now, in this particular part, I'll be substituting the value of n. N is what? N naught by 5. So hence, I'll just write it. N naught by 5 is equal to n naught into e raised to minus lambda t. So I can cancel off n naught here. So I'll get e raised to minus lambda t is equal to 1 by 5. 1 by 5 can be written as what? 5 raised to minus 1. Okay. So this implies lambda t can be written as ln of 5. So this is the value of lambda t. Now I can go ahead and use this value to address to next part. So lambda t is ln of 5. So let me just write it back. This is ln of 5. This is what we had. Okay. So therefore t will be equal to what? T will be equal to ln of 5 divided by lambda. Now what is lambda here? Lambda is obviously that is according to our decay equation. We had found that out. So I'll just mention this as ln of 5 into 2.303, okay, divided by 0.693 into 3, that is t half. Okay, so if we just substitute this value, we'll be obtaining the value of time as approximately around 7 years. Okay, so over here 7 years happens to be our right answer, my dear friends. Okay, so I hope this was clear. Now let me move on to next question, that is question number 44. Now 44th question is based on a concept. So it's a concept oriented question. I need not explain too much on this. When a PN junction diode is in forward bias, which type of charge carriers flow in the connecting wire? Now in the connecting wire will always have free electrons. So that's it. So 44th question we have cracked it. Now 45th question, a full wave rectifier with diodes D1 and D2 used to rectify 50 Hertz alternating voltage. The diode D1 conducts dash times in 1 second. Now, what is the frequency here? 50 Hertz. So, in 1 second, it should conduct 50 times. So, I can go ahead and answer to this question in this manner. Okay. Now, let me move on to 46th question quickly. Now, in order to solve this 46th question, I'll take help of, I'll be mentioning this part here directly. Now, over here, suppose if I consider the outputs from this NOR gate and this AND gate, if I consider these outputs as C and D, suppose if I write them as C and D, okay. Now, what is C here, my dear friends? Now, as you can see here, C is equal to, now, here we have A input and B input, and they are coming out through what? NOR operation. So obviously I can write this as A plus B whole prime. A plus B whole prime it is. Okay. Then what about D here? D, if we just address to, then D will be equal to, as you can see, these inputs are A and B again. So they are coming out from an AND gate. So I can write them as what? A dot B. Okay. Then the outputs from these two are C and D. Now they are entering into what? A NAND gate. So Y output, if we just go ahead and consider, Y is equal to what? C dot D here. This is what we have. Okay. So C dot D, it's prime. That is what we are going to understand it as, because it is a NAND gate. This is what we have. So C dot B prime, if you just answer to this, if you just go ahead and use this, so I'll be writing here in place of A, C, I'll be writing A plus B prime. Okay, this I'll put in a bracket, dot of A dot B. Okay, then I'll consider whole prime. Okay, because C dot D whole prime. Now let me just apply De Morgan's law once again here. So as we can see, C dot D is what? C bar dot D bar. C bar plus D bar. So we will be addressing to that. So I'll write this as A plus B whole prime. Okay. Then here we have dot. So I'll write plus, okay, into or plus A dot B whole prime. This is what we have. Now A plus B whole prime is what? A plus B again. Okay. Plus A dot B whole prime is what? A prime plus B prime. So if you just consider this equation, my dear friends, as you can notice, option C matches here very easily. Is it not? Now let me just take one pair here. If I put A as 1, okay, then A is 1, A bar is how much? 0. So 1 plus 0. B is 1, B bar is 0. So 1 plus 0, 1 plus 0, 1 plus 1, 1 plus 1 will be what? 1. Now let me take one more pair, 0 and 0 here. If I put A as 0, 0 plus A prime is 1, 0 plus 1, 1, then 0 plus 1 again, 1 plus 1, again it will be what? 1. So my right choice would be option C here. Okay, fine. So this is 47th question. Now let me, 46th question. Now let me go to 47th question, my dear friends. Question number 47. 47th question, if you just address to the energy gap of an LED is 2.4 electron volt. When LED is switched on, the momentum of emitted photons is. Now this particular question is based on de Broglie principle, okay, and linear momentum concept. So as you can notice here, we have lambda is equal to h by p. This is according to de Broglie principle. Okay, lambda is h by p. As well as I also know that E is equal to, that is energy E is equal to what? Hc by lambda. Now then from this I can write lambda is equal to what? Hc divided by E. Lambda is Hc by E here. So if I use this here, then I can see that the left hand sides are equal, then these two right hands must be equal. So therefore I'll mention h by p is equal to hc by e. So if you just cancel off h on either side, then I'll get p is equal to e by c. This formula we have already done in concept theory part, but still I just wanted you to recall this back. Now if we put the values of E and C respectively, now E is given as 2.4 electron volt, my dear friends here. So as you can notice here, let me erase this off. Okay, fine. So energy is 2.4 electron volt, and 1 electron volt is 1 into 1.6 into 10 raised to minus 19. So let me just use that, 2.4 into 1.6 into 10 raised to minus 19 divided by 3 into 10 to the power 8. Okay, so if you just simplify this, as you can notice, 3 ones are 3.8s are, so 0.8 into 1.6, bingo, our answer is 1.28, is it not? So 1.28 into 10 to the power minus 27. Okay, so our answer in this case, my dear friends, this is option D. Okay, 1.28 into 10 to the power minus 27 kg meter per second. So this was 47th question. So hopefully you are following what we are solving here. So let me just move on to next question, 48th question. In the following equation, representing beta minus decay, okay, the number of neutrons in the nucleus X is, okay. Now in beta minus decay, According to Saudy's group displacement law, we know that suppose we have a nucleus A X Z. Now this AXZ upon liberating beta minus, so here we'll get a product called BX plus 1. Just 1 minute. I'll change the notification here, notation. So okay, I'll take the mother nucleus M, okay, M Z A, giving rise to N Z plus 1 and A plus beta minus, that is E minus 1 0 plus energy. Right. So over here, as you can notice, atomic number is increasing by 1 but mass number remains the same. So you can make back calculation using the given expression. As you can see, 83 is the mother nucleus atomic number. 83 plus 1, that should be 84. Now 210 minus 84, that should give me 126. Okay, so this is our answer, my dear friends. Now let me move on to next question. Now question number 49. Now this is a straightforward question. Now as you can notice here, a body is moving along a straight line with initial velocity v0. Its acceleration is given as constant, okay, and its velocity becomes v from v0, and they want us to find average velocity of the body over the given time interval. Now as we can notice, average velocity v bar is equal to what? Net displacement. Net displacement, I'll just mention it as S here. Net displacement divided by time. Okay. Now what is net displacement? Net displacement is v square minus u square divided by 2a. That is net displacement, is it not? So I can mention S is equal to v square minus u square divided by 2a. Now use this here. Okay, so you would see that you will be getting option B here. V square minus v0 square divided by 280. So if you just use this value, okay, so this is 49th question. So it was quite an easy question. Now let me just move on to 50th question quickly. Question number 50, okay. A particle is in uniform circular motion related to one complete revolution of the particle. Which among the statements is correct? Now, this I need not answer. You can very easily go ahead and answer. You would have answered it correctly. So I can go ahead with average speed of the particle as 0 here. Okay. Now, 51st question. A body of mass 10 kg is kept on a horizontal surface. Coefficient of kinetic friction between the body and the surface is 0.5. The horizontal force of 60 Newton is applied on the body. What is the resultant acceleration of the body? They are asking. So over here, now resultant acceleration. To find resultant acceleration, let me just consider the situation in this manner. Now this is a body. Here we are applying the force F, and this is the direction of motion, and opposite to the direction of motion we will have force of friction. Okay. And I'll be considering normal reaction in this way. This is normal reaction here, and here we have self weight mg. Now from this free body diagram I'll be marking acceleration also in this direction. Okay, so from this free body diagram I can note that normal reaction is equal to mg. Okay, and also I have the value of F as what? Mu into NR, normal reaction according to laws of friction. Okay, then if you just use this, from this I can get F is equal to mu mg. Force is equal to mu into mg. Now net force in this on this body would be what? F minus mu mg. This should be equal to what? M into A. Okay, so according to that, I can get the value of A. If we just substitute the values and simplify this, we will get this as 1 meter per second square. Okay, so our answer to this question is 1 meter per second square. Now let me move on to question number 52 quickly. Okay, now 52nd question. As you can see here, we have a ball of mass 0.2 kg is thrown vertically down from a height of 10 meter. It collides with the floor and it loses 50% of its energy and then rises back to the same height. The value of its initial velocity they are asking. Okay, now for this question, we need to solve it in two folds. Okay, so according to given, I'll just mention K2 is 50% of K1. Okay, so I'll just mention that 50% of K1. Okay, and in case of K2, we have, as you can notice here, the ball is thrown downward. Okay, it will hit the ground with some velocity. Okay, so let me consider this velocity as V naught here, and here I'll write velocity V, and when it rises up back, let us consider that velocity of rise as U, or I'll say U naught. Okay, so this is what we can go ahead and take the symbols. So I'll just repeat once again. V naught is the velocity with which the body was thrown. V is the velocity with which the body hits the ground, and U naught is the velocity with which the body will rebound back. Okay, now this is where we can understand the demarcation here. So over here, as you can notice here, initial kinetic energy, if you just consider before collision, kinetic energy before collision, kinetic energy after collision. Now these are the two concepts that we are going to understand and apply here. So according to that, so I can write kinetic energy before collision. Kinetic energy before collision would be equal to what? 1 by 2 m into velocity is v square. Okay, and what is the value of v square here, my dear friends? V square, I can write this as what? V square is equal to v naught square plus 2gh. 2gh. As you can notice, g is 10 here. Height is how much? According to given, we have height of 10 meter here. So let us go ahead and use that. So I'll get this as v naught square plus 2 into 10 into 10. So this will be 200. So I'll write this as v naught square plus 200. Okay. So this is the value of v square. So therefore, kinetic energy before collision will be equal to what? Half m into v square, v naught square plus 200. This is what we have. Okay. Okay, fine. So we have made use of this value. So let me call this as my first equation. So this is kinetic energy before collision. Now similarly, I'll move on to next step here. So kinetic energy after collision. So kinetic energy after collision, this will be what? 50% of kinetic energy before collision. So I'll just write it as KBC before collision divided by 2 here. Okay, 50% means 1 by 2. So hence this will be equal to what? 1 by 4 times of kinetic energy before collision. So m into 200 plus v naught square. This is what we have. Okay. So, but what is kinetic energy after collision? So this will be half m into u square. Okay, u naught square. So here previously I had told you that the velocity with which it will rise above the ground is u naught. So that u naught I am using here. So half m u naught square is equal to 1 by 4 m into 200 plus v naught square. Now let me just simplify this. So I'll just cancel off m. So here we are left with 2. So I'll get this expression in this manner. So according to this, u will be equal to, or u naught will be equal to what? U naught will be equal to square root of 200 plus v naught square divided by 2. Now this is what we have, correct? Okay, so now maximum height to which this body will rise after collision. Okay, so as you can notice here, it is going to rise up to the same level, So for that reason, I'll consider here maximum height, that is h max will be equal to what? U square by 2g, because angle theta is 90 degree here. So hence I'll write u square by 2g, that is maximum height, and u square value I have this here. So I'll write this as u naught square by 2g. So according to that, I'll get this as 200 plus v naught square divided by 4g. Okay, so if we put in the values and substitute everything properly, then we will get the value of here, as you can notice, h is 10, and g value we can take as 10. So if we just simplify, we'll get v naught is equal to 14 meter per second. So this is the initial velocity with which the body was projected. Okay, I hope it is clear. Okay, now let me move on to question number 53 quickly. The moment of inertia of a rigid body about an axis. Okay, if you just consider, it depends on what? Position of the axis of rotation. So we can address to this question as option C, right? Then 54th question, if you just understand, 7 identical discs are arranged in a planar pattern so as to touch each other as shown. Okay, now you can see that they are touching each other, with one of the sphere being at the center of this arrangement. Okay, and they want us to find moment of inertia of system of 6 discs about an axis passing through the center of the disc and normal to the plane of all discs. Now it is perpendicular to the board, so along that axis we are supposed to find what? Moment of inertia. Okay, so according to this, we can consider firstly moment of inertia of discs. They are saying disc means its moment of inertia is what? M r square by 2. This is moment of inertia of a disc, is it not? About its about an axis passing through the center and perpendicular to the plane of the disc. Okay, so if you just address to this particular approach, as you can notice here, how many discs are there? Totally 6 discs are there. So accordingly, I can write it as mr square, and over here let me apply parallel axis theorem. Now suppose we have a disc here in this manner, the axis which is passing through this, okay, and another disc which is placed above. Okay, now this axis, if we just talk about this axis, okay, now these two axes are parallel to each other, right? What is the distance between them? The distance between them, these two discs will be what? 2r, right? So that approach we are going to apply here. So accordingly, I can write the net moment of inertia as mr square by 2 plus, I can write it as 4 mr square divided by 2 again. Okay, so this is where I can get the final answer as 27 mr square. Okay, so you just can go and have a look at this. With this approach, you can get the answer. Okay, 55th question. True length of wire is 3.678 centimeter. Okay, and length of this wire is measured using instrument A. The length of wire is 3.5 centimeter. Okay, when the length of the wire is measured using instrument B, it is found to have a length of 3.38. Okay, now in this question, as you can notice, the actual length is 3.678 and with instrument A it is coming to be 3.5. So that means measurement with A is more accurate. Okay, whereas measurement with B is what? More precise. So hence I will go ahead and mark option A as the right choice here. Okay, so I'll just move on to next question, 56. Okay, a stretched wire of material whose Young's modulus is y is equal to 2 into 10 to the power 11 Newton per meter square has Poisson's ratio 0.25. Its lateral strain is given as 10 to the power minus 3. Elastic energy density of the wire is. Now, elastic energy density, if you just consider over here, elastic energy density, it is given by 1 by 2. I'll write it as U is equal to half into Young's modulus into strain, square of strain. Okay, so according to this approach, if you just go ahead and use these values given to us, so I can write it as 1 by 2 into 2 into 10 to the power 11 into square of strain is 10 to the power minus 6. Okay, we should get the answer as what? 10 to the power 5. So our answer is option A. Fine. So let me come to the last three questions of this part. 57th question. A closed water tank. As you can notice, now this closed water tank, I can go ahead with this question. I can consider this to be a question based on Poiseuille's formula. So this is the standard answer that I can mark straight away. It's a conceptual question. Okay. Now 58th question. Over here 100 gram of ice at 0 degree Celsius is mixed with 100 gram of water at 100 degree Celsius. Final temperature of the mixture is how much they are asking. Okay, now over here I'll firstly find out the heat liberated in two cases. Now when you put ice in water, what happens? Ice will melt. Okay, and this melted ice will be converted into water at 100 degrees Celsius. Okay, so hence I'll find that heat first. So heat Q1, this is for what? 0 degree Celsius ice to 0 degree Celsius water. I'll just write it properly. So this is 0 degree Celsius ice to 0 degree Celsius water. Now this is Q1 here. Now Q1 is equal to mass into latent heat. Okay, mass is given as 100 gram. So into latent heat they have given in terms of SI, joule per kg. But I suggest why to make use of this. Instead of that, since we know the mass in gram, so I suggest you make use of it in calorie per gram. So it is 80 calorie per gram. So if you just use this here, so you'll get this as 8000 calorie. Okay, then let us go to the second step. Now this water which is at 0 degree Celsius, now its temperature has to be increased to what? 100 degrees Celsius. Now over here the picture, in this picture specific heat comes into play, right? So over here I'll write that Q2 is equal to, that is, what is Q2 here? It is heat required to increase the temperature of water at 0 degree Celsius to water at 100 degrees Celsius. Okay, so in order to have this, so I'll make use of mass into specific heat of water into rise in temperature. So rise in temperature in this case is 0 to 100. So I'll just write it as 100. Okay, so if you just substitute the values, then over here again I'll be obtaining this as what? 10,000 calorie. And remember, they have given this specific heat of water in SI, but I suggest you make use of that in CGS or in terms of gram calorie per gram per degree Celsius. So I can use this as directly 1. Okay, so this will be a best method for us, and over here I'll be obtaining Q2 as 10,000 calorie. Now therefore, what is the net heat that is required in this case? Delta Q, that is Q2 minus Q1, which is nothing but 2000 calorie. Okay, now this 2000 calorie, if you just equate it, now let me go to the last step of this solution. So I'll just mention this delta Q is equal to mass into specific heat into delta T. Now we are supposed to find this value of delta T. So if you just put the value of delta Q as 2000 and mass as 100, then 100 plus 100, because 100 gram of ice plus 100 gram of water, so it should be what? 200 here. So this is 2000, this is 200, and specific heat you can take 1. Okay, then I can get the value of delta T. Okay, in this case delta T comes out to be 10 degrees Celsius. Okay, so our answer is option A, 10 degrees Celsius. Okay, now I'll move on to 59th question now. 59th question, this is based on Carnot's engine. They have given PV graph. Now the simplest approach I would like to tell you is the work done during process AB. This is obviously isothermal, then adiabatic expansion. Now sum of these two works, I hope you can calculate work done as area under PV graph. So if you just apply to this concept, we should be getting the answer as 3000 joule here. Okay, so that is the work done. Now let me move on to the last question in this lot, that is question number 60. When a planet revolves around the sun, in general for a planet. Now over here, this is based on Kepler's law of planetary motion. So over here we always have to remember that when the planet is revolving around the sun, the angular momentum about the sun and aerial velocity of the planet, they are always constant. So option B is our right choice, my dear friends. Okay, so with this note, in fact I tried to give you a quick grub, and suppose you have any further queries, you can always go ahead and approach to us. We are very well situated in Gurudev PU Science College, one of the prestigious institutes in Dharwad as well as Hubli, and in fact we are catering the quality education. So come ahead and address to your queries with us. I'm hoping to see you back in my class. Okay, thank you very much. Have a nice time.